going to have a look at finding the area, circumference and perimeter in terms of pi. So we're going to find the circumference and perimeter first. Now with these shapes, what you would normally do is you'd identify, well, it's a circle, and you'd write down the formula for a circle. So we'll find the circumference, that would be pi multiplied by d. Any second step will be to substitute. So the circumference is equal to pi multiplied by, and d is 170. The diameter is the distance all the way across the circle. Now the next thing you'd do is you would then get your calculator and you would do pi multiplied by 170 and you would get an answer. Now the answer that you're going to get isn't going to be very accurate because you're going to have to round it. The answer you would normally get is 500,034.07075111103. Depending on your calculator, you might get more decimal places, and you don't want to write all of that down. So what you might do is do something like rounding it to, let's say, 2 decimal places. So you get 534.07 as your answer. But that's not accurate because it's been rounded. Now, what finding the answer in terms of pi is all about is getting a 100% accurate answer. And the way we do that is that we don't multiply by pi. So when we say 170 multiplied by pi, we just write 170 pi. And we use pi like you would use a letter in algebra. You pop it on the end and you say, we'll multiply by this when we know what it is. And with pi, we do know what it is, but if we multiply by it, we'll get a horrible decimal number that we're going to have to round. So leaving our answer as 170 pi means we've got a 100% accurate answer. Do the same thing for question 2. We'd write down the formula. Circumference is equal to pi d. Now in this question we don't have the diameter, we've got the radius because it only goes halfway across the shape. So if the radius is equal to 86, then the diameter would be 2 lots of 86. So 86 times 2 is going to give us 172. That means when we substitute the circumference, it's going to be equal to pi multiplied by 172. And we're not going to do that multiplication because we'll have to get an answer that we'll have to round. It won't be accurate. So we'll just use our algebra skills and combine those terms together to get 172 pi. Now for question 3, we don't have a circle, so we're going to find the perimeter of this shape. Start off with finding what the circumference for a full circle would be. So that would be pi d. But then because it's only half a circle, we're going to have to divide it by 2. Now if we do divide by 2, then the part of the perimeter we found is the curved edge, which is half of a circle. And you'll notice that we haven't used the 220 centimeters. So once we've found half of pi d, we would have to add on the 220 centimeters. And if I highlight that on the shape, you can now see we've enclosed the entire shape for the full perimeter. So step 2 would carry on as normal. We're going to substitute. So we're not going to multiply pi and d together. We're going to ignore pi for now. D is being divided by 2. So the diameter, 220, is being divided by 2 to give us 110. And because the pi is part of that term, we have to pop that on the end of the 110. And then we're going to add on the 220. There's no further working out to do with the 220. And then that is actually our final answer. The perimeter is 110 pi plus 220 centimeters. Question 4 works in a similar way. So we have the perimeter of the shape. Firstly, we pretend we're finding the perimeter of a full circle, which would be pi times d. But then this is only a quarter circle, so we need to divide by 4. And if we do divide it by 4, 1/4 of the circle would just be this curved edge. So you'll see we also have a radius 120 and a second radius here as well. We've got 2 straight edges which are both radiuses. So we're going to add on 2 lots of the radius. Just to show we added on 1 lot of the diameter. So now we've worked out what the formula is, we can substitute. So again, we're not going to multiply by pi, we're going to leave pi alone. We have d over 4, and we don't know what the diameter is yet, but the radius is 120, so the diameter will be 2 lots of 120, which should be 240. I'm saying d over 4, we're going to do 240 divided by 4, which will give you 60. And because pi is part of that term, we have to put pi on the end. Then we've got the adding on the two radiuses. So if one radius is 120, two radiuses would be 240. So the perimeter of the entire shape is 60 pi plus 240 centimetres. Moving on to question 5, so we'll follow the same process. The perimeter is be equal to, and again we've got a shape derived from a circle, so we're looking at pi d for a full circle. But in this shape, we've only got 3/4 of a circle. So we're going to need to divide it by 4 to find 1/4, and then multiply by 3 to find the 3/4. Now, again, that won't give us a full perimeter. It's only going to give us the 3/4 of the circle, the curved edge. So you can see we've got two straight edges left over. So what we need to do now is add on the two straight edges, and the size of those is they are 115, and that is the radius. So we have two lots of the radius to add on. Now we know the radius is 115, like I just said, but we're going to need the diameter as well, and we don't have that. So the diameter is two lots of the radius, so two lots of 115 will give us 230. So now we substitute. So we are going to ignore pi, so that will give us 3 multiplied by the diameter, 230, and then divided by 4. And that should give you 172.5. Pi is part of that term, so put pi on the end. Then we need to add on two lots of the radius, so one lot of the radius is 115, two lots of the radius would be 230. So the final perimeter would be 172.5 lots of pi plus 230 centimetres. Now we're going to go back through the easy questions, but this time we're going to find the area in terms of pi. So again, you're going to write down the formula. The area of a circle is pi r squared, pi times a radius twice. Look to see if you've actually got the radius. Now in question 1, we've got the diameter because 170 is all the way across. So the radius is going to be half that. So the radius half of 170 is going to be 85. So you do the same thing that you would do if you're going to work at the question normally, which is going to substitute. So the area is equal to pi multiplied by the radius, 85 squared. Now, just like the circumference and perimeter, we're not actually going to work this out fully because we'll get a decimal answer we'll have to round. We're going to keep this as an accurate answer. So we are not going to multiply by pi. But you do anything else you can do in the question. And what we can do is we can square 85. And 85 squared should give us 7,225. And we're not multiplying by pi, so we pop it on the end. And then that's our answer, 7,225 pi centimetres squared. Doing the same thing with question 2. So write down the formula. Normally the area would be pi r squared. We're going to substitute. So we're going to leave pi as it is, but the radius is now 86, and that is squared. So for our final answer, we'll ignore the pi. We're not going to multiply by pi, but we can do 86 squared. And that's going to give us 7,396. And then again, we need to put pi on the end. Now, question 2, very similar. It's not a full circle. So firstly, pretend you are going to find a full circle. The area of a circle is pi r squared. But then this is a semicircle. It's only half of a circle. So we need to divide that by 2. So then we substitute in. The area is pi times, and again we don't have the radius, we have the diameter, which is 220, so the radius would be half that, and half of 220 is 110. So when we substitute, pop in 110, and that number's been squared, and then we divide our answer by 2. So then we actually do the calculation. We type it into our calculator. We're going to leave pi off. We're not going to bother with a pi. We're not going to put that into our calculator. We can do 110 squared, which would give you 12,100. And then we can divide that by 2, which should give you 6,050. And then this is where you put the pi on the end, because we haven't multiplied by pi, so we still need to include it in our calculation. So the area is 6,050 lots of pi centimetres squared. Question 4 works the same way. So firstly, work out a full circle. The area of a full circle is pi r squared. Then question 4 is only 1/4 of a circle, so we need to divide by 4. So we substitute, leave pi as it is. The radius is 120, and 120 is being squared and then divided by 4. You can then type all of that into calculator, excluding the pi button. So 120 squared to give you 14,400, and then divide that by 4 to get 3,600. And then because we didn't multiply by pi, pop it on the end. So the area is 3,600 pi centimetres squared. Then moving on to question 5, again we have a formula derived from a circle. So the area of a circle is pi r squared, but we have 3/4 of a circle. So we're going to divide by 4 to get 1/4, and then multiply by 3 to get 3/4. So our formula should look like this. So then we substitute. The area will be equal to 3 lots of pi times the radius squared, so 115 squared, all divided by 4. And then for our final answer, we're going to type all of that into our calculator except for pi. So we'll have 3 multiplied by 115 squared, and that should give you 39,675, and then we need to divide by 4. So our final answer is going to be 9,918.75, and then because we didn't multiply by pi, put pi on the end. Moving on to the median questions, now we're looking at arc lengths and sectors. So we'll look at sectors first, and again you'll do this in the same way you would do it if you're going to try and find a normal final answer. A normal circle would be 360 degrees, but for the first question we only want 145 out of the 360 degrees. And then for an area we're going to multiply it by pi r squared, so that would be pi times a radius 77 squared. Now you're going to work out as much of that as possible to find the area. So for example, we can do 77 squared, and that should give you 5,929. We've got the multiply by pi, and as usual these, we're not going to multiply by pi, we're just going to pop it on the end. And then we've got the fraction, so how do we deal with the fraction? Now, if we use a calculator, and we did 145 divided by 360, I would get 0.4027 recurring. And that's not a very nice looking number. It kind of defeats the point of not multiplying by pi to keep the decimal numbers under control. So we really don't want a number like that in our calculation. So what do we do instead? Well, what we're going to do is we're going to simplify the fraction. So looking at 145 and 360, this looks like a fraction that can be divided by 5. So 145 divided by 5 will give us 29, and 360 divided by 5 will give us 72. And then it's always worth checking to see if we can simplify that again. But I don't think we're going to be simplifying any further with that 29 and 72. I can't think of any numbers that will go into both. So we're going to leave the fraction like that. And then that fraction is multiplying the rest. So we need to write a multiply sign in between the fraction and then the number with the pi on. And that would be our final answer. One final thing to consider is sometimes a fraction will simplify to something that will multiply by your number and give you a reasonable answer. So always test out if it's worth multiplying by the fraction. If you do get an odd answer, then just leave it as a fraction, that'll be fine. So let's try the same thing with question 2, finding the area. So firstly, we want the fraction of the shape we want. We don't want a full circle. We want 59 degrees out of 360 degrees. We'll find the area, so that'll be pi r squared. So pi times the radius, 108 squared. Then I'm going to work out as much of that as possible. The first thing to do is see if we can simplify the fraction. Now 59 looks like it's a prime number, so we're not going to be able to simplify the fraction. So sometimes we are going to leave it as it is. And then we can't multiply by pi because we'll leave it in terms of pi. We can do 108 squared. And that's going to give us 11,664. And then we do need to multiply by pi, we'll just pop it on the end. Now with this question, if you did multiply by the fraction, so you divided by 360 and you multiplied by 59, you do actually get somewhat of a reasonable answer. And what you would get if you multiply by the fraction is you get 1911.6. Again, that would be pi. So always look at different ways where you can simplify that fraction as much as possible. Sometimes a fraction is simpler, sometimes a decimal is going to be simpler. Moving on to question 3. So to find the area, a full circle will be pi r squared. We don't want a full circle, we want 295 degrees out of the full 360 degrees. And then the formula is going to be pi r squared. So first thing to do is to try and simplify the fraction as much as possible. Both those numbers can be divided by 5, so we'll try that first. And that will give us 59 over 72. That's divided the numerator by 5 and the denominator by 5. 59 is a prime number, so we're not going to be able to divide any further. And then we're not multiplying by pi, we'll leave it in terms of pi, but we can do 103 squared. And that'll give you 10,609, and then put the pi on the end. Now, if you were to divide by 72 and multiply by 59, you would get quite a complicated decimal answer with some recurring numbers in there, so it's probably best to leave it as 59 over 72. Moving on to question 4. Again, the same method. So we only want 129 degrees out of 60 degrees. We're going to multiply it by pi r squared, with the radius being 92. The first job is going to be to try and simplify the fraction. And 129 looks like it can be divided by 3. And 129 divided by 3 is 43. Then 360 divided by 3 is 120. And then 43 is a prime number, so we're not going to be able to simplify any further. I'm not going to multiply by pi, but we can do the 92 squared. And 92 squared is going to give us 8,464. And we put the pi symbol on the end. And then again, if we took the 84,064 and divided by 120 and multiplied by 43, we wouldn't get the nicest decimal number, so we could leave it like this. If you were going to write it as a decimal, then you would get 3032.93 recurring pi. So again, you've got to make a kind of judgment on if the decimal or the fraction is going to be the less complicated version of writing the answer. The exams will tend to give you more than one possible answer in these kind of things. Now for question 5, that's going to work the same way. We've got a room at the top for question 5. So we're going to find the fraction of the circle we want. We want 217 degrees out of 360 degrees. We're going to multiply r squared, and the radius is 120. And then what we're going to do is simplify the fraction and then do as much of the calculation as possible. Now the fraction doesn't look like that's going to simplify, so we can leave it as it is. We can do 120 squared, which should give us 14,400, and put pi on the end. Now with this question, if we actually did take 14,400 and divide it by 360 and multiply it by 217, we do actually get a whole number answer. So the area would be 680 pi. Now this question is probably most representative of what an exam question would be, because what would happen is it would be designed to get a whole number answer at the end. Now we're just going to run through the same questions, and we found the area, so now we're going to find the arc length, and the arc length is just the curved length. If you ask for the perimeter instead, you'd have to add on 2 lots of the radius. So it's going to work the same way. So to find the arc length, firstly, select the proportion of the circle you want. So we want 145 degrees out of 360 for a full circle. Multiply it by the formula, so that would be pi times the diameter. Now for all of these, we're given the radius halfway across the circle, so the diameter is going to be double that. So double 77 is going to give us 154. Then you do as much of that as you can on your calculator, except you're not going to be multiplying by pi. The simplification is the same as we did for the area, so that was 29 over 72. And then this time, it isn't actually any multiplication to do. We're timesing by pi, we're timesing by 154. So we just write multiply by 154 pi. So let's do the same thing for question 2. So the arc length is going to be, take the fraction, 59 over 360. We're going to times that by pi d. And the diameter is going to be double the radius, so that would be 216. When we worked with this fraction last time, we couldn't simplify it. And we've got no more calculator to do, so I'll multiply by 216 pi. Now for this question, if we did take 216 and divide it by 360 and multiply it by 59, we do get a reasonable number and we get 35.4. So that'll be 35.4 pi. Now question 3, so the length is going to be 295 parts out of 360 multiplied by pi. Now the radius is 103, so the diameter will be 206. So writing that up, we can use simplification from last time we used this fraction, which was 59 over 72. And that's been multiplied by 206 lots of pi. For question 4, again, write as a fraction how much you want. You want 129 degrees out of 360 degrees. Multiply it by pi d. Now the radius is 92, so the diameter is 184. So then simplify this as much as you can. We simplify to 43 over 120. That's how we work with that fraction, and it's been multiplied by 184 lots of pi. And we took 184 and we divided it by 120, and we multiplied it by 43, you would get 65.93 recurring lots of pi. So again, make a decision if a short decimal, maybe a recurring number, is more simplified, or if a complicated looking fraction is more simplified. You know, the more decimal places, the more recurring decimals, the more you might want to leave it as a fraction to be more accurate and more clear. Now looking at the final question, so the arc length is going to be 217 out of 360 multiplied by pi multiplied by the diameter. So diameter is 2 lots of the radius, so 2 lots of 120 is 240, and we can pop pi on the end. And if you did 240 divided by 360 multiplied by 217, you would get 144.6 recurring. And yet in each one of these questions, in the easy and the medium sections, we haven't rounded once, so we haven't lost a single bit of accuracy. And we're leaving it up to whoever uses these numbers to multiply by pi and to round if they wish to, and they can choose how many decimal places to round to, depending on what they're doing. So now we're going to look at reverse questions. Now the trick with reverse questions is just to do what you would normally do. So we're looking for the area of a circle. Yes, it's told us the answer, but what we would normally do is we say the area is equal to pi squared. Now, because we're trying to find part of the question, the radius, which is labelled with an R on the diagram, and it's given us the answer, we're going to work backwards. So we're going to take the 12,100 pi, and we'll look at what we normally do and do the opposite. So normally, if we square the radius, then what we need to do is do the opposite of squaring, which is the square root. And if you find the square root of 12,100, you're going to get 110. And that 110 is going to be the radius. There's one more thing to consider, is that normally we multiply by pi as well. And because we're doing this in terms of pi, we're not multiplying by pi. So we're just going to leave the pi symbol on the end of our answer. So the radius will be 110 times pi centimetres. Question 2 would work the same way. So we have the area of a circle. So we think, well, how do we work that out? We do the area is equal to pi squared. Now it's given us the answer, which is 6,724. So to work backwards, we're going to have to look at what we normally do and do the opposite. So if we're normally squaring, then we need to be rooting. And if you find the square root of 67,024 using a calculator, that should give you an answer of 82. So the radius is 82 pi. Now, in the question, it doesn't ask for the radius, it asks for the diameter. And the diameter is the same as two radiuses. So the diameter will be twice as big, it'll be 164 pi. So when you get your final answer, always have a quick look at the question, because it might be something tricky, like it's not asking for the radius, it's asking for something else. You need to do a simple correction at the end. Moving on to question 3, we have sector area. And again, we do the same thing. We think, what would we normally do to find the sector area? So we would look at the angle we have over the total number of possible angles, 360. And then what we would do is we would multiply by pi r squared. Now it's given us an answer. So it's given us 5,415 pi. So we have to do the opposite of what we would normally do. And we're going to reverse order. So the last thing we do is square the radius. Now we actually do know what the radius is. The radius is 114. So if we're multiplying by the radius squared, the opposite of that would be dividing by the radius squared. And the radius squared is 114 times 114, which would be 12,996. So we divide by that number. The next thing is to multiply by pi. So now that we divide by pi, because we're working in terms of pi, we're going to ignore that. Then the next thing is that we would divide by 360. So the opposite of that is multiply by 360. I would type all of that into our calculator, then we should get the angle theta. So I'm going to do 5415. I'm going to divide it by 12996, and then I'm going to multiply it by 360. And that gives me exactly 150 degrees. All I've done is looked at what I would do normally to find the answer, and because I have the answer, I'm looking for part of the question, we're going to do the opposite of all the things we would normally do. For question 4, we're finding the arc length. So to find the arc length, what we'd normally do is we would take the proportion of the arc of the full circumference, which would be our angle over 360. We would multiply by pi d. Now the radius is 102, so the diameter would be 204, it'd be twice as big. And it's given us an answer. The answer is 47 pi. So we do the opposite of that. Working backwards, the last thing we do is multiply by 204. So we need to do the opposite of that, which is dividing by 204. Next thing is multiplying by pi. So we want to divide by pi, but because it's in terms of pi, we're going to ignore that step and just have pi as part of our answer. The last thing we do is divide by 360. So the opposite of that is multiplying by 360. And then putting all of that into a calculator should give us an answer for theta, a missing angle. So I'm going to do 47 divided by 204 multiplied by 360, and that should give you 82.94 degrees to 2 decimal places. The last thing to note with the angles is that I haven't been using the pi in the calculation. Now, the reason why I've kind of ignored the pi is because it doesn't really matter about how large the area or the length is. Because with the angles, you can't get bigger than 360 degrees. So no matter how large your circle is, it's not really going to change the angle. So multiplying by pi isn't actually going to change the angle. A circle 3 and a bit times bigger would still have the same angle. The angle's just going to scale up for the larger shape, but still remain the same number. So now we'll have a look at question 5. So again, we're finding the area. We need to find the part of the circle it is, so it's going to be 262. And for an area, we're going to multiply by pi squared. And for this question, we don't know what the radius is, so I can only write r squared. It's given us an answer, and the answer is 8,806 pi. So we need to work through this and do the opposite of each thing. So the r squared, we're going to leave that until the end. What we're going to have a look at first is the fraction. So we want to divide by 360, the opposite is times by 360. And then if the numerator, that's normally multiplication, so the opposite of 262 will be divide by 262. And we'll get an answer for this bit first. So if you work all of that out, so 8806 times 360, divide by 262, then you should get 12,099.847 to 3 decimal places. Now, I still haven't finished. We had the r squared. And so the opposite of squaring is a square root. So the radius is going to be the square root of our number. And if you work out that square root, you should get 110. And then because we haven't used pi yet in the calculation, we're going to put pi on the end. So the radius would be 110 times the size of pi.